Good morning. Happy Thursday. Today, part of your lesson, we are going to talk about network topologies. Okay, so what you should have open on your computer besides this presentation is your 9.3 note-taking Google Doc from my class website. You should have filed and made a copy of that, put your name on it, and then you are going to fill out this document as we go through this presentation. Okay, I will go slow and I'll make sure you guys have what you need to complete that document. Okay, so there are many different ways, this will click, to set up a computer network. Okay, in this presentation, we're going to talk about the common ways of how to organize a network. So a network, for example, at DMA, what's the network? Well, the network is how we access the internet at school. So when you log into your school computers using your username and passwords, you are logging on to the DMA network. Okay, so working remotely from home right now, some of your parents are doing it. They probably have to log in to their company network in order to access certain documents and information that they need to work. So ask your parents after you watch this presentation if when they're working from home they have to log into a network and ask them about it. Okay, so we are going to talk about topology. Okay, so that's the first thing on your note sheet. So topology means a topology is how things are related to each other in a specific space, how they're organized. So topologies don't just refer to networks. It could be anything in life. It could be a classroom. It could be anything, any space. So classroom, restaurant, how the mall is laid out. Okay, so how anything is organized. So again, a topology is how things are related to each other in space and how they are organized. Now, a network topology refers to the layout of computers, okay, devices or computers on a computer network. So at DMA, the topology is how the DMA network is designed. So there's computers in my classroom, there's computers in Mr. Green's classroom, then there's the iPad cart, then there's the laptop cart, and then each teacher has their own computers within their classroom as well. Okay, so that's a little bit about topology. So we are now going to talk about some of the most common network topologies. Okay, so one of the first common topologies is a bus topology. So put that in your second part of your notes there. A bus topology, as you can see here, every computer is connected to this central cable here. So this computer 1, central cable, 2, down to the central cable, 3, down to the central cable, and you'll see that here. Okay, it's easy to connect computers because it's connected to a linear bus. That's what this line is called here, the linear bus. All right. The only problem with this is if this linear bus here, this cable would break, say right here. What would happen is if the hub was over here, like the main internet connection was over here, and this broke here, all of these computers down here would not have access to the internet. Okay, if the cable was to break down here, these two computers would not have access to the network or the internet. Okay, so depending on where the break is, it would depend on which computers still have access to the network. Okay, if the entire network shuts down here for some reason, it's also really difficult to locate the problem. Okay, now since there's only one network line here, all communication goes through this network line. So if this computer is trying to go to this computer to communicate to it, right? That is going to come out here, go down the line to this computer, right? But now what if this computer and this computer are going to try to communicate at the same time as these two? What's going to happen is it's going to slow down the process because it's going through that same linear line. So it's not going to be that fast. Okay, so it must travel this line, and the more devices that are connected to the bus, the more the chance increases that one device is going to need to use that, more than one device, excuse me, is going to need to use that at the same time. Okay, so that's the main drawback of that network. If two devices attempt to use the bus line at the same time, it creates collision like we talked about, as it like interferes with one another. Okay, and that right there is what makes this type of topology less desirable than other more up-to-date topologies. Okay, this topology really isn't used anymore except on extremely large-scale networks that have smaller networks within them. Okay. Our next common type of technology is going to be a ring topology. Put that in your second part there of your notes. Ring topology. Okay. Each node. Okay. A node is a device. So a computer can be a node. A laptop can be a node. Your iPad, your phone can be a node. So here you see all the computers are nodes. Each node is connected to two nodes. Okay, so this one's connected here, and it's also connected to this one. And you see that by these arrows here, all of the communication travels in the same direction around this ring. Okay. The main benefit of this is that it's very organized. Okay, so if this computer needs to communicate to this computer, it's going to go all the way through. And if this computer needs to go here, it's going to go in the same direction. So there's not going to be any interference necessarily because it's all moving in the same direction versus the bus line where it could interfere with one another. Okay, a main disadvantage of this type of network is if one computer goes down, the entire network will be impacted and cannot function. So if this computer goes down, right, all of these computers here are communicating through this computer to these two computers. So if this computer or node goes down, the whole network is going to be down, which is a very, very huge deal. Okay, because of this, ring topologies are really not popular today compared to what they once were. Okay, our next topology you're going to write down is a star LAN. Okay, so LAN, you guys should know, stands for Local Area Network. Okay, it has a hub and many spokes, as you can see here. Okay, this is the most common type of network topology today. It's easy to think about it kind of like a bicycle wheel and the spokes. There's one central node, which is the hub, okay, and each computer connects to that hub, okay, individually. So it's not going through like the ring or the bus. Each computer is connected to that central hub, okay. If this computer needs information, connected to that hub. This computer needs information, it's directly connected to that hub, and the information is sent directly back to the destination. It doesn't have to go through any other type of computers. One benefit of this setup is that if there's a problem with one node, it's separated and has nothing to do with it. So if this computer goes down, these computers aren't affected. But remember with the ring topology, that was the biggest disadvantage. Okay. This type of network is also easy to expand. The only limitation is on how many computers can be added. Depends on the size of the hub. Okay, so if you have a large hub, you could have a bajillion computers, say, but if you have a small one, you may only be able to have like 5 or 10. It all depends on the size of the hub. Most common home computer networks, so what you're using at home right now, is this type of network. So you have the hub and the router, right? So your hub's going to be like your modem, right? So your internet comes into your house, goes to your modem, and your modem sends it to your router, and then your router puts out Wi-Fi, okay? Or you could be directly hardwired into that modem as well, all right? The main downside of this network is that the central hub stops working, the network goes completely down. So I'm sure you have experienced this before. If you do not have an internet connection in your house, internet is not coming into your modem, okay, and your modem's not working, so therefore you cannot get Wi-Fi in your house. Let's see here. Okay, that's good for that one. And now let's come to here. We have a mesh LAN, and then we have a fully connected mesh. So those are two common types. Write those down or type those down on your note sheet. So a mesh LAN, okay, which is this here, it's a partially connected mesh. So what does partially connected mean? Okay, partially connected as you see this computer is connected to this computer, right? But it's also connected to this computer. So it has to travel that system. So from this computer to communicate to this one here, it has to go all the way through the system. So not all the computers are directly and fully connected. Okay, you can see the lines. So this computer connects to this one, then to this one, or it can go this way. So it just depends on the setup, but they are not all connected. Okay, in a fully connected mesh, like this one here, all of the computers are directly connected to one another. You can see the lines. So this computer connected here. This computer connected there to there, then down to there, and then down to there. So that's the difference. In a partially connected mesh, all the computers are not connected, but in a fully connected mesh, they are connected. Okay, messages sent on a mesh network can take several possible paths or routes from that source. Okay, so like I said, if this computer wants to connect to this one, it can go boom, 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 boom. That's a little bit of a longer path. Or it can go boom, boom, boom. Okay, so it could take 3 steps or 1, 2, 3, 4, 5 steps. Okay, so it really just depends, but there's a lot of different routes it can travel, which is good when multiple computers are communicating at the same time. All right, so let's say that this connection here breaks. How is this computer going to connect to this one? Well, it's called hopping, okay? So it will hop from one device to another. So since this is broken, this computer's going to have to go boom, 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 and kind of take an alternate route, a less direct route, okay? But this one here connects to the fully connected mesh. You can connect to any computer at any time, okay? The advantage of using a mesh network is that it provides redundancy, meaning it's more reliable. There's multiple ways to connect to different computers. However, it is very expensive, okay? A fully connected mesh is the most expensive of all of the topologies, all right? Now we have a tree LAN, which is a hierarchy. You guys should know what a hierarchy is by now. Okay, it's a group of devices that are connected with a linear backbone. Okay, so a tree is a common type of network. Type that down. All right. So the backbone here would be these two. So this tree LAN has to be symmetrical. So if it has one computer with two computers here, this side has to have one computer with two computers here. Okay, but this is the backbone. Okay, the simple tree LAN, a central root or device or hub, is connected to other devices. So this is your central root or hub, and it's connected to other devices, as you can see. Okay, there is a point-to-point link between each of the second devices. So boom, boom, and then those devices are connected to more point-to-point connections, links to other devices. So then this is connected to these two, and this is connected to these two. Okay, each device in a network has a specific number of devices connected to it through the lower level of the hierarchy. So if we were to come down here to continue this computer would have two, this computer would have two, this computer would have two, and this computer would have two. Remember, it has to be symmetrical. So this computer couldn't have one and this one have two. It has to be the same on both sides of the tree. Okay, tree topologies enable you to expand an existing network as needed. So if this is a computer network and this is how it starts, then you need to expand. It's easy to add more computers down here, and you just keep expanding through the hierarchy. All right. Disadvantages of a tree topology are depending on the length of cable that you have, that's going to be the length in between the devices. Okay, so the longer the cable that you have, the longer you can move away from that central hub, that main hub, all right? If the backbone line breaks, so say this line breaks here, every single device on this side of the tree is going to go down. Same thing here. If this cable breaks, everything over here is going to go down. So with that, it's a big disadvantage, okay? And it's also more difficult to configure and wire than other topologies, okay? So that's a negative point of the tree LAN. Okay, so for the most common types of topologies, you should have ring, star, mesh, and tree. Okay, looking at your third question, what happens if a cable breaks in the star topology? We talked about that. So if we come back up here to star, all right, if something breaks, if one of the connection cable breaks like this, what happens? This computer is disconnected, okay, but everything else still works. So if a cable breaks in the star topology, that connection to the specific device breaks. So if it's to this one doesn't work. If it's connection to this one, it doesn't work. However, if the central hub goes down, like we said, if your modem stops working, if internet doesn't come into your house and your modem's broken, say, then the whole network goes down. So it just depends if it's the hub that's broken or if it's a single connection. All right? Keep moving on. So we know that LAN stands for local area network. Okay, WAN stands for wide area network, and that WANs cover a large geographic area. Okay, so let's say that, for example, that one of your parents works for Bank of America. Bank of America, say in Wilmington, has a local area network in its building, right? It's all in one building, it's local. But that local area network can then be a part of a wide area network for Bank of America. So Bank of America, no matter where Bank of America locations are throughout the country, they are all connected through that WAN. Okay, but then each individual site can have its own LAN. Okay, I hope that makes sense. So like I said, WANs cover a large body, a geographic area. LANs are on the smaller side. Okay, so you see here in this diagram, the link machines could be in the same building or different buildings or even different countries. Okay, I know it's probably a little bit confusing, but think of it like I said with Bank of America. I'll repeat that example. So Bank of America is a national company. Okay, if you're working from home and you're working from Bank of America, you have to log on to the network. So you're going to be logging on to the network for your specific local network. So if you work in Wilmington, yes, you're going to be logging onto your local area network in Wilmington. But then that local area network in Wilmington is part of a larger, wide area network of all of Bank of America's across the country. Okay. So cables connect devices in a network. Okay, so that's your last part there. How are computers physically linked? They are physically linked through cables. Okay, and the most common type of material to do this is an Ethernet cable. Okay, so if you look at your modem or your router or your modem in your house, you will see that there is an Ethernet cable connected to it. Okay, in school, all of your computers are connected to our network using Ethernet cables. And there's kind of a cool way to show you this in school, but since we're not there, I can't show you. But yeah, so that's the last part of your note sheet. We're going to continue with the presentation here, though. Okay, so looking at this slide, topologies have a common goal, okay? That users, computers, devices can all share resources and data. Okay, so think about it here for a second. When would you need a LAN and when would you need a WAN? I kind of gave you a couple examples of these, okay? And then think about different situations where you could use the different topologies as well. Okay, so hopefully, I know it's a lot of information. Hopefully you guys are okay with this. If you have any questions, you can comment on the band thread or shoot me an email. Have a good day.